The ESP family of microcontrollers has some great features in connecting to Wi-Fi networks. And in this empty Arduino sketch and with this serial monitor, I'm going to show how to do that. Here the first step is to include the library for the Wi-Fi. Here it is. But this library here works for the ESP32 only and not for the ESP8266. So I'd like to change this line here with this set line like that, and here it is a dependency of the ESP32 microcontroller with this Wi-Fi library here, and here is the ESP8266 dependence with this Wi-Fi library here. The next step is to include some lines about the Wi-Fi credentials. Here's the definitions of the SSID of the network and the password. But in this presentation I'm going to hide this in the include file for secrecy. So this is changed with these lines here. That's an include file with the credentials, which is not shown for the audience here now. So I'm going to use that one here. The next step is to include a start command for this serial interface, like that. And I also like to include a line here to avoid the garbage shown in the serial monitor at startup in this with this controller. So here we go to the next line and show this start connection label information. Then we include a Wi-Fi start command. Here the Wi-Fi is starting with these credentials here, SSID, definitions of network and the password, and that is from this include file here, which is secret to the public, to this presentation. So now that is it. It's in order to establish the connection with the Wi-Fi network. But we like to have some debug information about the startup procedure, so we include some more lines here about that. When the network is not yet connected, we show some dots here in the serial monitor, and that stopped and is halting when the connection is established. So we can get some few dots here in order to connect to the network, but then it stopped. After that, we like to include some code for information about the network also. We have to avoid these brackets here, like that. Format it somewhat. So here we can show the IP address allocated to the controller after the connection is done. So that's pretty much it. So now we like to compile and upload this sketch here. And in this case we have an 8266 microcontroller. So we start the compiling and upload procedure here. And in this case we have to connect the GPIO 0 terminal to ground in order to upload this sketch. And after the uploading is done, this terminal has to be disconnected again in order to run the software, the sketch. So now we are done with the upload and reset the controller, and here we see this garbage information and the start to connection label, and here we see some dots showing that the connection is going to be established. And after the establish has been reached, the dots has terminated, and we have this message here showing the IP address to this microcontroller. So that's it. So now we are connected. If there is going to be no connections. For example, if this SSID is a different one, we can see what's going to happen then. We can compile and upload that sketch into the controller. So now it's compiling and uploading, and then when it's done, we reset the microcontroller. So now it's uploaded and resetting it, and there we see that the start connection label is shown and the dot is showing also, but now the dot is going on showing forever that the connection is not established. So if there are something wrong about the connection, there are going to be no stop in the presentation now of dots here, going and run forever. So what we like then, if we not are able to connect the Wi-Fi connection, we like to try another one, and that's going to be shown in the next chapter. In order to stop this false connection to the Wi-Fi network, we like to terminate this try and make another try. So in order to do that, we like to limit this dot presentation here by introduce an integer I, which can be 5, for example, and we like to extend this while loop dependency with an dependency of the I variable here, which is going to be decreased each time it is read. And we'll look into the case where this I is greater than 0, and after that, when it's below 0, it stops. So then we like to try another network connection, and then we copy this code here to the area here and try another SSID definition here and password, and the int is not necessary anymore because it's defined here. So now we make another try with this network also. So if that succeeds, we get this message here, and we'll see how that will work. So here we will upload the sketch again by pressing this button here. So now it's compiling, and sketch is uploading, and when the uploading is done, we can reset the terminal to the microcontroller. So here it is done. We reset the controller, start the connection, and the dots here for the first try is terminated after some time, and then we try the other one, and that connection is succeeding. So then we have been able to connect to the second Wi-Fi network. It can be interesting to see the status of the Wi-Fi connection during these different tries or different Wi-Fi connections. So in order to show this, we'd like to present some code here. This status method can be watched better if we include some lines here about the additional status labels here. We can show which labels have which integer value here in this code here. And then we can also use a code like this to show what kind of status it is at this stage here. So this is the status before we do anything about any connections. So here we do the first one. So after the first try we could show the status again to see how it went, and then we make the other try and we could see the status after the second try here, like that. So now we can compile this one to see how this is going to work. So running the compiling and uploading here. Like that. We can clear the output here now. And now we are resetting the controller now, and here we see the different labels for the different values for the labels here. So the first test shows 7, and that is it is not connected. So then we try the first connection, and that also will report as 7 code, not connected here. But the second try reported 3 value for the status, and 3 is that it's connected. So here we can see the what about for the connection procedure when you have a number of connection testing in the sketch. It can happen sometimes that there is not going to be any connections when it should be, and in those cases you can try to reset the connections before applying the begin here. So here we could add a line about disconnect the Wi-Fi before we connect it again. So that can maybe help in some cases then before the Wi-Fi begin is applied. So so that's worth a try. There is, however, a much more clever solution to this, in fact. If we exchange these definitions here with this one, where we add an additional library to the Wi-Fi library called MultiWifi Multi library. It's different libraries for the ESP32 and ESP8266 here. So you have to put it in the correct positions here for these different uses. So here we define an additional variable here, Wi-Fi multi. It's the same variable for those 2 versions, because we have put it from, we have captured from different libraries, but the same variable here. So this we can use in the setup utility here. So we can change all those code here. We don't need this anymore. We can change, in fact, all code here in a setup procedure with one line here, and this could be repeated as many times as we like for all different kind of networks here. So here we could at last put in our working connection. So these utilities will check into different number of networks and use what is the best one all those networks here and connect to that one. So in order to have a debug information on this, we can add some more code, like this code. So here we test the connections here. We test which is running in a time frame here, connecting timeouts, which is a constant 5 seconds, like that. And within this time frame, we look into the Wi-Fi connections here, and we can also show which of these network addresses used and the IP address. We can also show the strength of the signal here, the RSSI signal. So if you compile this one, we could see how it works. Pushing this button here and compile it. And upload it. And then when it's uploaded, we can reset the microcontroller like that. And now we see that one of those networks is found and connected here, and it's a very strong signal. So you can see that also here. To see what these signals mean, we can add some additional code for interpreting this value here, because there are some intervals for those different values here for very good, low, and very low signals strengths. So compiling this one. And upload it. And then resetting the controller, you see that this signal 550 minus 555 is a very good signal here. So that's it. Thank you for watching.